Welcome back to the next lesson in this unit. It's going to come from section 9.2. Our targets are to identify the focus, directrix, and axis symmetry of a parabola and graph the parabola, and write the equation of a parabola given the vertex and focus. Okay, so we have two different types of parabolas, and you didn't know this probably when we did this in quadratics way back at the beginning of the year. We started, and this is what we're ending with. But parabolas can be vertical or horizontal. Well, we saw the vertical ones when we looked at our normal y equals ax squared plus bx plus c equations. We did our horizontal ones when we did square root functions. That's basically what a sideways parabola is. But we're going to talk about different characteristics, and these equations are going to look a little different than what you know are used to seeing. When we're doing conics and graphing that way, we actually will write the equation in terms of the squared value. So whichever value is squared, that's what the isolated variable. In this case, on a vertical parabola, the x is squared. Okay? The focus is 0p. The directrix is y equals negative p. The axis symmetry is x equals 0 for the standard form. Which way it opens up? If p is positive or negative, it opens down. If p is positive, it opens up. So let's just pretend we have a parabola that looks something like this. What do these values mean? Your focus, let's say it's going to be like somewhere here. Focus is inside of the parabola. You're going to have this line called the directrix, which is y equals for the vertical parabolas. And what's so important about that? Well, if you pick a point anywhere on that parabola, even though I didn't draw this to scale very well, obviously not, the distance from that focus to the line called the directrix is the same. Okay, so that's why the directrix and focus, that's why we identify them. That's how you kind of define a parabola. From the focus to the point, and the directrix to the point, it's the same distance. I know it's not to scale, but they are the same distance they're supposed to be. A sideways parabola. Okay, sideways parabola, we only graph the top half of a sideways parabola. We call that a square root function. But the sideways parabola, that's if we graph both sides at once. And we'll show you how you can do that in the calculator in a bit. Focus is the opposite. The x and y variables switch. So instead of 0p, it's p0. So p0 right here. And our directrix this time is a vertical line. It's part of the graph, it's that line. It's equidistant. So if I pick a point on my graph, the distances between the directrix line and the focus point on the graph are the same. If p is positive, it opens to the right. If p is negative, it opens to the left. Axis symmetry is y equals 0, or x-axis, if you will. X equals 0, that's the y-axis, right? And this one is the x-axis. So that's your characteristics. You want to have those down in your notes. We're going to go do some problems using this information. Okay, so graph 2y equals x squared. Which type of parabola is this? And look back at your notes you just took. Vertical or horizontal? Well, the x is being squared, which indicates that's a vertical parabola. So this is like the regular old parabolas we're used to. So if it's a vertical parabola, vertical parabolas have the characteristics stated below. A focus of 0p, a directrix of y equals negative p, and axis symmetry of x equals 0. Okay, if p is negative, it opens down. If p is positive, it opens up. So we're going to find all these things, okay, and we are going to identify them and graph these points and these values. Or graph the parabola, I should say. So, focus. We need to find p to find the focus. Here's how you're going to do it. We know that 2y equals x squared. We also know this. We also know that x squared also equals 4py. So if we look, x squared and x squared are the same, y and y is the same, that implies this equation. That implies that 2 equals 4 times p. If I solve this equation, I get p equals 1/2. And then the rest of this just falls into place. 0, 1/2. Y equals the opposite of 1/2. And x equals 0. So the focus, 0 up 1/2. The axis symmetry is 1/2. And then we just have to graph the equation. Now, if we were going to graph it, I would probably use my graphing calculator, and then you'd have to solve it for y. No matter what equation you're graphing, vertical or horizontal, or when we get to other types of conics later, you have to solve for y. So y equals x squared over 2. We could do it by hand probably, or we could just simply go y equals x. Let's actually make a fraction here. Alpha y equals, a little easier on us, x squared over 2. And we can graph it. Pull the picture out here that we get. We can also, we'll do it by hand. Let's get some table values. Second table. And we'll get close to 0 here. Okay, 0, 0, 2, 2, negative 2, 2, 0, 0, over 2, up 2, left 2, up 2. There we go. So that's all I'm looking for. I want the focus and directrix found and labeled, and then at one point either side of your vertex. And you're good to go. Now let's look at a y squared equation. Y squared, well, y squared, that indicates it's a sideways or horizontal, however you want to say it. So sideways, they have these characteristics. PO is the focus, directrix is x equals negative p, axis symmetry is y equals 0, and it opens right, p is positive, and left if p is negative. Same thing, y squared equals 20x, but y squared also equals 4px. So we have 20 equals 4px. Or 20 equals 4p, excuse me, leave the x out of it. Divide by 4, we get p is 5. P is greater than 0, so it opens to the right. So we can now use that to find the rest of these pieces. We know that 5, 0 is the focus. We know that x equals negative 5 is the directrix. Symmetry y equals 0. So 5, 0, 1, 2, 3, 4, 5. Negative 5, 1, 2, 3, 4, 5. So now we just have to graph this. Once again, we have to get y by itself. We square both sides of the equation, we get two things. Y equals positive square root of 20x, and we have y equals negative square root of 20x. And why do we need both? Well, I'll show you why. When we go to graph this, if we type in just the square root of 20x, we're going to end up with just half our graph. See, look at this one. You only get that top half. We know sideways parabola, that's only half of the parabola. So that's why when you square both sides, you got to remember to graph the negative square root of 20x. And the negative's on the outside, so it's not going to make anything imaginary. Don't freak out. So now if we do this, we can trick the calculator into graphing that sideways parabola for us. And we can go to our table, and we can get a table of values because there's going to be two y outputs. So if I look, 0, 0 is 1. Let's just go down here. And I see at 5, I get 10 and negative 10 as my two outputs. And here 5. So I'm going to go right 5, up 10. There's 10. Leave those extra dots that we're counting. And then we go down 10, which will be right here. It looks a lot like the graph that we just did in our calculator. So that's the trick to graphing with the calculator. Do the positive and negative square root when you isolate y and y1. Okay, so Now we're going to switch gears and we're going to try and write an equation if we're given information. If we're given a focus with a vertex at 0, 0, or if we're given a directrix with a vertex at 0, 0, first we'll start with the focus. We're going to focus of negative 2, 0. Well, the focus is negative 2, 0. Look back at your notes. Is this going to be a y squared or an x squared parabola? Well, in y squared parabolas, it's p 0 for y squared. So this has to be a y squared equals 4px equation because p comes in the x spot. So if p is 0 or p equals negative 2, then we can solve this and figure out what our equation is. 4px, so we just plug it in basically. We get y squared equals 4 times 2, or y squared equals 18x. I will let you guys do the before. Now down here, just so you know, when you're doing this, this is an x squared parabola. So x squared equals 4py, because the p comes in the y coordinate. Okay, look where the p comes. Wherever the y coordinate or the p is, it's an opposite squared value. It's in the y coordinate, it's an x squared. It's in the x coordinate, like here, it's a y squared parabola. So what if we're given a directrix and the fact that the vertex is at 0, 0, and it wants to find the equation? So we can do that. X equals negative 3. Well, we know x equals negative p. That's the equation for the point p. So negative p equals negative 3. So that means p equals positive 3. So we know if it's an x equals directrix, that this indicates that this is a sideways or horizontal parabola. So if it's a sideways, it's a y squared equals 4px. Put negative 3 in for, or positive 3 in for p. We end up getting y squared equals 4 times 3x, or y squared equals 5x. Down here, the directrix to the y equals, that means it's a vertical parabola, and that's going to change everything, right? It's going to be x squared equals 2/3. So it looks like we hit our targets. We wrote equations, the second one for the vertex and focus, and we identified the focus directrix symmetry of both vertical and horizontal parabolas. Have these notes ready for tomorrow. We'll see.